When we're working in calculus, one or two words that will come up are even functions and odd functions, and I want to make sure that we understand what they are. At the end of this lesson, you'll be able to determine if a function is even, odd, or neither. Even and odd functions, we actually have been dealing with even and odd functions earlier in this chapter when we've dealt with whether a function is symmetric with the x-axis or the y-axis or the origin. We totally have been dealing with even and odd functions. If a function is even, you'll notice we have f of negative x is equal to f of x. It's symmetric with respect to the y-axis. So we've already done this. So now if we see that, we'll just call it an even function. If a function is symmetric with respect to the origin, we can now call it an odd function. Just a couple of things. Even functions, just a few examples of them. If I have like x squared, x to the fourth, x to the sixth, even functions, they have even powers. Generally, if I have an odd function, we might have x to the third, x to the fifth. They have odd powers. That's not the only way to tell if a function is even or odd because they don't always have even or odd powers, but that's one kind of quick way to check whether it is or not. Right, in this example, it says to determine whether the function is even, odd, or neither, and then use a graphing utility to verify your result. When we're determining it, we will definitely want to do our tests for symmetry to decide that. The first thing that I like to do so that I don't have to test all three right away is decide, is it even or is it odd or do I think it's neither? And the first thing that I see is this 3 sitting here, which is a power, it's a 1/3 power, kind of thinking that it's going to be odd. So that's the test that I'm going to perform first to see if it works. So if you remember our odd test, it was symmetry with respect to the origin. We will plug in a negative x for our x and a negative y for our y. And just an FYI, whoops, f of x really is just the same thing as y, so I'm just going to replace that right now. So replacing y with negative y and x with negative x. I'll keep this as a negative y. And then the cube root of a negative number is a negative number, so I can actually put the negative on the outside instead. And I'm still not able to compare that because it's not the exact same function yet. To get rid of that negative y, I'm going to multiply both sides by a negative 1. And when I do that, I'm going to get y equals the cube root of x. And notice I got exactly what I started with. So I did prove that the function is for sure odd. And if I wanted to use a graphing utility to verify my result, you'll notice that if I were to graph it using my graphing utility, I'll get a problem that I believe looks like that. It's kind of a sideways John Travolta. And you'll notice that if I were to flip that 180 degrees or flip it upside down, I do get the exact same graph. So it is an odd function. Just one quick note on this. Can a function be even and odd? I'll let you think about that. If a function is a function, there is no way that it could be even and odd. It can't be symmetric with respect to the y-axis and the origin. So you should know now more about even and odd functions.